have seen that there are 4 types of the salt. A salt of strong acid, strong base and a weak acid. A salt of the strong acid and the weak base, and the last salt of weak base and weak acid. Now we are going to see their hydrolysis, and in the last lecture we have seen that the salt of the type strong acid and a strong base, they do not undergo the hydrolysis reaction. When they are hydrolyzed, they just get dissociated and their ions are formed. This hydrolysis, this is nothing but actually the reaction of the cationic anions of the salt with that of the water, that is simply called as the hydrolysis. Now we are going to see the hydrolysis of the salt of the type strong base weak acid. So the example of this is we are going to take the sodium acetate. When the sodium acetate is dissolved in water, it dissociates completely as the acetate ion and the Na plus ion. This is how the dissociation takes place in the aqueous medium. Now the acetate ion which is formed, that reacts with the H plus ions which are formed from the weak dissociation of the water, and those H plus ions get reacted with the acetate ion and form the unionized acid, that is the acetic acid is formed here. Now therefore we can write the hydrolysis reaction as the acetate ion and the Na plus ion which we get on dissolution of the sodium acetate plus water, there is a formation of acetic acid, Na plus and OH minus, that means the NaOH is formed. In this reaction, as the H plus ions from the water, very small concentration of H plus ions is formed, that concentration is used to form the unionized acid, and only the OH minus ions which are dissociated with H plus from the water molecule, those OH minus ions remains free in the solution, and therefore the solution's nature becomes alkaline or the basic. So therefore, whenever this type of the salt of a strong base and a weak acid, they are hydrolyzed, the solution is made basic. Actually here, the H plus ions are used. Therefore, the ionization constant of water will disturb. So to compensate or to keep the ionization of water constant, more water is dissociated, and as more water will be dissociated, more of the OH minus are formed, and this is what is the reason why the solution becomes alkaline in nature. So this is the hydrolysis reaction of this type of the salt. This reaction we have written. For such type of the hydrolysis reaction, the equilibrium is produced in the reaction, and therefore for such type of the reaction we can write the hydrolysis constant, which is nothing but equal to, actually this is a equilibrium is obtained in the reaction, and therefore this is actually other equilibrium constant. Here the equilibrium constant is written the concentration of the formed products divided by the concentration of the reactant. Actually here Na plus is common on both sides, hence Na plus is cancelled out. Therefore what the formula will become, the concentration of the acetic acid into concentration of hydroxyl ions divided by concentration of the acetate ion into water. Now here the water concentration is such a large that it remains constant, and therefore it is not introduced here. And this water constant and equilibrium constant is termed to be a new constant which is called as the hydrolysis constant, and this hydrolysis constant is equal to the concentration of a free acid which is formed into concentration of a free base divided by the concentration of a unhydrolyzed salt, that means which does not hydrolyze, which remain unhydrolyzed. So this we can write this as, this is nothing but the form of free acid into this free base which is in a ionic form in the solution and which is free, those hydroxyl ions, and this is the concentration which is nothing but unhydrolyzed salt. So the hydrolysis constant, this is equal to concentration of free acid form into concentration of free base divided by the concentration of the unhydrolyzed salt. So this is termed the hydrolysis reaction of the salt. Now here what we have considered is acid, which is formed the acid which is actually concerned here is acetic acid, and we know that this is a weak acid which dissociates very weakly as the acetate ion and the H plus ion. As this is acid, so we can write ionization constant for the acid, which is equal to concentration of the acetate ion formed into concentration of H plus divided by the concentration of undissociated acid. Now we know the ionization constant for the water, that is Kw, which is equal to concentration of the H plus ion into concentration of OH minus ion. Now what we are going to do is we are going to take Kw divided by Ka. This we are going to perform. So Kw divided by Ka, which is equal to concentration of H plus into concentration of OH minus divided by Ka. This whole term we have taken here. Now H plus will get cancelled, which is common. Numerator and denominator. These terms will remain as it is. Therefore, as these terms will go to the numerator, so Kw divided by Ka becomes concentration of acetic acid into concentration of this OH minus divided by concentration of the acetate ion, and this is nothing but Kh. Therefore, Kw divided by Ka is equal to Kh. For the salt of strong base weak acid, their hydrolysis constant is equal to the ionization constant for the water divided by the ionization constant of the acid. Now the next term of degree of hydrolysis, which is denoted by small h. Now what is degree of hydrolysis? It is the fraction of the total number of molecules which are hydrolyzed in the hydrolysis reaction. That fraction is simply called as the degree of hydrolysis. This is a fraction, total number of molecules that undergoes the hydrolysis reaction. This hydrolysis reaction we have written here. This shows that all the molecules does not undergo the hydrolysis reaction. A small fraction that undergoes the hydrolysis reaction, and that fraction is simply called as the degree of hydrolysis. So now we are going to see the relation between the hydrolysis constant and the degree of hydrolysis. For that we have again considered the hydrolysis reaction in the equilibrium. So in this reaction we consider that the initial concentration of the sodium acetate is simply C. This is the initial concentration of this sodium acetate. Obviously as the initial concentration is this, therefore these two are not formed, therefore their concentration initially is considered to be 0. Now when the hydrolysis reaction will take place, after the hydrolysis reaction we consider that H fraction of this is hydrolyzed. Unit concentration, out of that a small fraction H is hydrolyzed that we have considered. Therefore a fraction of these two products will be exactly H. The degree of hydrolysis, that is nothing but the fraction which is hydrolyzed. The H is the fraction hydrolyzed, that means that these two will be formed exactly of the H fraction. So these will be the fractions at the equilibrium present of these two products. Similarly now, therefore the fraction of the sodium acetate which will remain unhydrolyzed after the equilibrium will be, obviously we can consider this as the unit. Out of that H fraction has been hydrolyzed. Therefore the concentration of a sodium acetate which remain unhydrolyzed will be 1 minus H. Therefore the concentration of this sodium acetate and the products which are formed at the equilibrium will be, these are only the fractions which are present at the equilibrium. How we will calculate their concentration? Simply multiplying these fractions by the concentration, and we know that the initial concentration is C. Therefore the concentration of the sodium acetate at equilibrium is C into 1 minus H. The concentration of acetic acid and sodium hydroxide at equilibrium will be CH and CH. So these are the concentrations at equilibrium. Now we want to obtain the relation between degree of hydrolysis and hydrolysis constant. So therefore we write first the formula for hydrolysis constant. This is what is the formula we have written. The concentration of free acid, free base divided by unhydrolyzed salt. So these are the concentration. We have substituted the concentration by these terms. Therefore we get that KH is equal to CH, this concentration CH, this concentration CH, and this is C into 1 minus H. So this will be equal to C square H square divided by C into 1 minus H. Now here a fraction which is hydrolyzed H, if it is very smaller than 1, obviously the fraction which hydrolyzes it is always very much smaller, and if H is very small, therefore H is a much less than 1. That means this is very near to 0. Therefore, this we can write as 1 minus H will be equal to 1. Therefore, what will equation becomes? KH divided by this we substituted as 1. Therefore, C square H square divided by C. Now, therefore, we will cancel one of the denominator C. Therefore, KH is equal to CH square. And therefore, H square will be KH divided by C. And this is the H square. So we will take only H. So H will be equal to square root of KH divided by C. This is what is the relation between a hydrolysis constant and the degree of hydrolysis. Now we know that KH is equal to KW divided by KA. So we will substitute KH. So this will become KH is equal to KW divided by KA divided by C. Therefore finally for degree of hydrolysis we have got the equation as H is equal to square root of KW divided by KA into C. This is what is the equation for degree of hydrolysis of the salt of strong base and the weak acid. Now we will obtain the equation for the pH of this type of the salts. We want to calculate the pH. Now to calculate the pH, what we will do? First we will consider the ionization constant for water, which is equal to H plus concentration into OH minus concentration. So therefore, only H plus and concentration will be equal to simply KW divided by OH minus concentration. Now, here, see here. The equilibrium concentration of Na plus and OH minus will be exactly same. That is nothing but the CH. That means Na plus and OH minus both will have the same concentration, that is C into H. Same concentration we are substituting here. Kw divided by C into H. Now we know the formula for H, we are going to substitute that. So concentration of H plus ion is equal to Kw divided by C into Kw divided by Ka into C. Now we are going to solve this. For this purpose, what we will do? We will all take all these terms in a square root sign. So this we want to, if we want to take in a square root sign, we will have to write that square divided by this also square, and this is as it is because already it is in a square root. Now the same term will get cancelled. So what will remain? The remaining terms are H plus ion concentration is equal to square root of Kw is remaining, 1 of the concentration is remaining, and divided by Ka. Right? This will become as Kw into Ka divided by C simple. Now we are going to take the negative logarithm of all these terms. So minus log of H plus is equal to minus log of square root of Kw into Ka divided by C. Square root in the sense raised to half. So this becomes minus log of Kw into Ka divided by C raised to half. Instead of square root, we can write a power half. Therefore, this equation becomes minus half of, this is the rule of a logarithm. The logarithm of the term which is having power, that power comes in a multiplication. So, kW into Ka divided by C. Now, we are going to apply the log inside. Therefore, let this be minus half as it is outside. Now, the logarithm of these two terms. There is multiplication in these two terms. Therefore, there will be addition of their logarithms. So, log of Kw plus log of Ka. And this term is in a denominator, that means in a quotient. Therefore, we can write this as minus log of C. This is how we can write. Now, what we are going to do is, we are going to take that negative sign inside. This negative sign will multiply inside. So, minus log of h plus is equal to half as it is. We are only going to take the negative sign inside. So, minus log of Kw minus log of Ka plus log C. This negative will become positive here. So, this minus log of h plus nothing but pH, which is equal to half of minus log of Kw is simply pKw. This is nothing but minus log of Ka is Pk plus log C. So, this is what is the equation to calculate the pH of the solution of a salt of the strong base and weak acid. The solution which is formed on a hydrolysis, the pH of that solution can be calculated by using this formula, which is pH is equal to half of pKw plus pKa plus log C. This is what is the equation. Next time we will see the hydrolysis of salt of strong acid and a weak base.